continuous atmosphere, and then it was all ablated away.
Yeah, and I think based on what you're saying, Alicia, there wouldn't really be any EDOs because things kind of vaporized that didn't get.
I have
Or they would be kicked out or eaten already by now, right?
I have a more strategic question. Was this kind of a one-off thing for the whole solar system?
Ooh.
Or were these roving rogue planetesimals causing problems elsewhere?
Well,
Any evidence of that?
I think that the Earth-Moon system is like the largest moon in proportion to the planet, depending on if you count Pluto as a planet, because Pluto and Charon are very.
You're in dangerous ground there.
I didn't take a side either way. You'll note I'm very carefully.
Go ahead and Pluto can be a planet.
Yeah. Okay.
We can make things up as we go along.
All right. So
this
maybe
is planetary science, damn it.
So maybe that would imply that Pluto was in impact combination because you have.
Is a moon always the result of an impact like this?
No.
Depends on how. Yeah, depends on how fast it's going.
So, or the angle, or all these things.
Venus is going really slowly backwards. That was hit by something huge. I don't know what the current hypothesis on Mercury is. Do you think that was a larger planet and it got reduced down to its mantle?
Oh, that's an interesting idea.
Uranus is straight up tilted.
Yeah.
Uranus is tilted. Neptune is way denser than we anticipated, isn't it?
So then no.
I don't think so.
No.
But
then Neptune has Triton. So if it grabbed one, it could probably also eat one.
Triton is basically
KBO.
A poster child for capture. But Venus, I think, is a good example of how are you going to get rid of an entire planet's worth of angular momentum. And this is a classic thought with planetary science, is that you have a pile of these planetesimals that have formed in terrestrial planet space, and they're all jostling each other. One of the outcomes is that especially if you've got a retrograde impactor, is that you eliminate the angular momentum in that particular system. Another is you make moons. So this is, from the astrobiology point of view, some people have said, well, Earth-Moon system is really rare because this is kind of an unusual thing, getting whacked by something the size of Mars and making a moon. But we have 3 terrestrial planets that are the size of Mars, and at least 2 of them got whacked by something the size of Mars.
I think the counter argument to that is it seems like statistically it's more likely that you're going to integrate most of the mass of an impactor. What was unusual about the moon is that you threw a bunch of mass off.
Right.
We don't know how common that particular conformation is because we only have our solar system.
We have 2 data points.
Yeah.
And so one yes, one no. So it should be somewhere around the range of 50% plus minus 45. But I'm sure that various people have integrated these numerically and thought that producing a moon is somewhat rare.
I think the astrobiological argument is that the moon is one of the key steps you need to form complex, intelligent life, because you need a moon to help you deal with impactors and help your orbital mechanics. But because we don't see a lot of intelligent people, I think we don't see aliens, basically. I think there's kind of a little bit of backtracking of, well, we don't see aliens, and this is one of the filters that we think exists. Therefore, statistically, we think it doesn't happen very often, which, I think you can make a strong argument that that's not a good idea to do yet. But I think that's
So
why.
you're aligning yourself with Enrico Fermi? Because that was the Fermi paradox, is if the aliens were so smart, why aren't they coming and talking to me? Because I'm really smart too.
Yeah, not necessarily, but I think that's
Well,
that's a little bit too much of an aside, even
Well,
for me. That's
I'm just paraphrasing Fermi, but that's the Fermi paradox.
Yeah.
Why haven't we seen them?
Yes,
Um,
that is what I'm citing, and I think that does sometimes inform astrobiologists' views on the physics of solar systems.
Did anybody in the physics community in the 1870s say there can't be electromagnetic waves because I've never seen any?
I'm sure they did.
Yeah. Oh, just an aside. Anyway, let's get back to the subject at hand.
Thank you all for your ideas. I think that harkens back to how there is a lot of lively debate around the models of the moon formation, and hopefully we'll see more as more people get interested with ISRU development.
So wait, I would like to go back to that. Have we ever found an NEO that looks like the Earth or Moon? Is anyone aware if that's a thing?
An NEO that has a
Spectral signature similar to like the Earth and Moon that we think is like a remnant of this impact.
no.
Most NEOs come from the inner main, though,
Right.
like 60%.
Well,
Yeah.
the lifetime of NEOs is on the order of 20 million years.
Okay.
So what fraction of that is of 4.5 billion? So the probability would be small.
Okay.
Okay, so with the formation moon, there's definitely a significance to ISRU. So a giant impact would have produced a moon much more similar to a volatile, depleted version of our Earth's mantle, rather than a chondritic asteroid. Giant impact would have also produced a really hot moon surface, so it would have surrounded it by this magma ocean. The magma ocean would be mineralogically differentiated, which is just really that idea that the denser, heavier things sink, the lighter stuff go to the top. And therefore, that would be called the chemical stratification of the moon. Also, extremely important, obviously, the moon does not have plate tectonics like the Earth does. The Earth has that kind of mixing and moving things around, cycling the crust out. So the moon's chemical stratification is more or less preserved in that sense. On Earth, we learned about the geological stratification and stratigraphy by people like digging canals in England, I think the story is, and they observe the strata. Also, generally speaking, you go to the Grand Canyon, well, you see the strata, very cool. So for a discussion question, do we think it's possible to do something like dig trenches on the moon? What kind of technical difficulties may that present?
I have a question. He was talking about drilling and trenching, I think it was.
Yeah.
Is it just trenching is like long drilling?
Yeah. So digging a long trench.
Okay.
Yeah.
Okay.
Yeah, does anyone have an opinion on digging trenches on the moon? Technical difficulties that may
I personally can't do it. You give me a few $1 billion.
Yeah, and a shovel.
Yeah, a shovel.
Well, I think in all this trenching, he's talking about going down a few meters at most.
Yeah.
And if you want to actually expose some of the differentiated stratigraphy, that would be hard to reach.
Why so, Dan?
Well, magma oceans are hundreds of kilometers deep.
Yes,
So I think it would be difficult to dig a trench that deep.
that's fair.
Yes. Also, yeah, well, it's just some ideas rolling off of this. If anyone thinks, how would we date some sort of trench or even some sort of like very long core? What would we use to kind of date something like that?
So maybe like what if we use impact sites, like the boundary between like where everything became magma and where things didn't magmify, and we could maybe get some strata there. Would that make sense?
Yeah, that sounds good to me. And do we think there's like a better way or a different way other than digging like these moon trenches to maybe like date strata or really just observe this like chemical stratigraphy.
Blow up the moon.
Maybe a different idea, or maybe no ideas. Okay, no one's got anything on that. We'll move on.
Does anyone know if it's easier to core things in low gravity? Like
That's a
you
great
talked
question.
about a really long
That
core.
is
Yeah.
what to talk about.
Excellent.
Okay, great. I'm looking
Right?
forward to
Mining and
that.
microgravity, I believe.
Well,
Yeah.
wait, the moon isn't microgravity. The
But,
moon
like,
is low gravity.
But it's less gravity than.
Yeah, but I think
What's this?
microgravity produces a different set of problems
Well, I
than
don't
low
know.
gravity.
Sure.
Well, the fundamental problem in any sort of coring is you need to have something that produces stress on the rock in order to break it up.
Right.
And the way you do that on the Earth is you just make the drill rigs really heavy and you put mass on them. So your big crutch is gravity. So if you kick that crutch away, you're down to 1/6. That's a big change. You're down to essentially nothing. That's a huge change. And you need to figure out how to deal with Newton's third law and things like that.
Okay, Dan, so if someone gave you infinite money and said, I want,
No,
A core.
no, you need to direct this question elsewhere.
fine,
would
everyone.
Put a rocket on the back and just shoot it down.
Oh,
Oh, okay.
Add
Alright.
gravity to the moon.
How do you add gravity to the moon?
Terraform the moon.
No, wait, that doesn't add gravity.
Add mass.
Add some atmosphere and some.
How?
gas.
Make a little bit black hole.
How do you add mass? How do you add a significant amount of mass?
Go to the gym.
Go to the gym.
oh.
You fracture.
Wow.
Right.
Well, I think
That's a
it's-
good idea. Could you?
I think it's
you
going to be
crack the
tough
moon?
to
What'd you say?
violate the
Could you
Uh,
crack the moon?
laws of gravity.
I don't know where you get like the water needed.
You could melt. There's ice
Afterwards.
around. There, ice
Yeah.
exists in space.
Suppose if you've
What
got
about
the
like
infinite money
explosive
strategy.
coring? Like, what if you put like
That was
dynamite
Alicia's
into the?
idea.
Well, no, she said a rocket. I'm saying.
My
you-
first idea was blow up
The
the moon.
shooting thing.
My second idea
Okay.
was a rocket.
Accelerator vertically.
Use a lot of force and then you get what you want.
Well, because if you're going for particularly, I want a scientific stratification. Why don't you just like do a bunch of directed blasts down and then like send a camera to see the strata in the hole that's left?
Yeah.
Well,
For-
what would happen with the debris that flies out? Would it
True.
kind of end up
Yeah, that's
depositing back into the hole?
yeah. I think you would have to probably excavate the whole like the moon hole.
Space back.
Sorry. Yeah.
Might, all the debris might hit the camera you're trying to send down.
Well, so you would drill the hole, take everything out, then put the camera
I
in.
can think of like a million reasons why that camera would fail.
All right, let's go. Let's go, Nicia. Tear my idea apart.
You would just lose signal because
So I put it on a wire. Don't make it wireless.
How deep is the Martian mold experiment digging? Could you do something like that that
Yeah.
isn't, blowing up the moon?
Oh, well, I think the point is like you have to get through the anthracite crust before you see anything that
Yeah, how big
isn't
is that?
Yeah, but
anthracite.
could you make like a really
And
large
orthosite.
version of the mold?
Anorthosite. I'm sorry.
Anthracite, you burned in your fireplace grate.
Oops.
and
Okay.
orthosite?
Yeah.
Anorthosite.
There's no ice.
Anorthite.
Anorthite. Or like the
Anorthite?
anorthitic. Would it be anorthitic crust?
Or anorthitic, well, never mind.
Well, that brings us to our next part, which is the
But let's talk about how thick this crust is, and it's literally hundreds of kilometers.
Yes.
Just the anorthite is.
Yes.
Yeah.
And so, but that it might have some interesting accretional depositional stratigraphy. But it would be odd, to say the least, since stuff is plating from the bottom rather than falling from the top.
The crust isn't dense because it floated.
Well,
So in theory, it's like easy to break through.
well,
I mean, it regolith.
Relatively
You need to-
dense,
you need to-
but
you need to hit more rocks with a hammer.
right.
We have a whole bunch of anorthite down at the Exolith lab, and you're welcome to go break it into small pieces.
Okay.
Like, that's
And-
a trick, but okay.
Yeah. You seem a
And-
little too happy offering this to us, Dan.
Can I take some home?
Well, no, we're selling it to
You can buy it.
we're selling it to the scientific community for Mars Highland Simulant. But the bottom line is that although it is a relatively light rock, the key thing is relative, and it is a tough rock. So that would be every bit it would probably be harder to drill through than granite,
Really?
really.
Why?
It's all about the Gibbs free energy of the crystal structure.
Mhm.
And this ain't trivial.
Well, then why are they trying? As
Because
opposed to,
there's
like-
treats underneath it.
Yeah, but there's treats in other places. Right?
Well,
Yeah, that's
And
true.
yellows. Is that not easier?
Well, I think this is a scientific coring that we're trying to do. This is a theoretical scientific coring to see the evolution of the moon.
Yes, the Earth's of the Earth, the Moon, the formation of the Moon, and it's the Lunar Magma Ocean (LMO). So what you guys are referring to, the treats underneath the surface, is the creep. Creep being creep with a K. It's potassium, rare earth elements, and phosphorus, and that's found underneath this anorthite crust. It's above, though, are olivine and pyroxene kind of accumulated heavy stuff that's sunk together because it doesn't really like to bond with that. It also doesn't really like to join up and bond with this anorthite crust. So it's sitting there in the middle, which in this depiction is that red zone. And again, this all formed from the molten magma ocean. So it's a good thing to keep in mind the differentiation of the crystals as we move through time. Also, a really cool point that I thought Dr. Crane brought up was the importance of exploration. So the Apollo soil samples showed the snow white particles of anorthosite when they came back, which is just a cool way to confirm some of these models we have and ideas of how things formed over time from that LMO, the Lunar Magma Ocean. Okay, so now we've got the kind of modern day minerals of the moon. Beneath the anorthosite, there is the creep layer. To go over that again, that's potassium, rare earth elements, and phosphorus. It formed by not chemically integrating with the top anorthosite crust, and it also didn't integrate with the olivine-rich mantle. Currently, the creep is it's in that layer that's beneath the crust, but also some of it gets exposed near the surface in the Mare basalt impact melt. Also in the lunar highlands, the impacts can remove crust and expose creep. And the creep is what we're going for with ISRU. We're trying to get to that because that's kind of the important resource. So some questions. Once we exhaust exposed creep, such as in the highlands, how would you go about extracting the other creep beneath the regolith? Obviously, I think we've had some discussion centered on that, but if anyone wants to reiterate or ping off those points. And then another follow-up, what advances ought to be made in our study of regolith properties to successfully extract creep material? And this is the material that's beneath the crust surface, not the exposed stuff, such as in the highlands.
There's like a bunch of really interesting materials deep in the earth. Do you think it would be easier to get at the creep on the moon or like drill significantly far into the earth? Which would be logistically more viable?
The Earth is easier because you don't have to send stuff up there to
Yeah,
drill in the first place.
that's true.
Gravity.
Gravity. Yeah, we just talked about that.
Gravity helps you drill down.
Yeah. Well, we're talking about like
Yeah.
deep, deep stuff on the earth versus the
How
stuff
deep?
on the moon.
How deep?
I don't know. This is a
What does
theoretical.
deep
Deeper
mean?
than the Marianas Trench.
Deeper than we're currently drilling.
Okay, well,
What was that Russian one? It was like
7, 8 miles in.
Well,
13 kilometers.
you have several problems when you go down. First, it gets hot. You also encounter significantly hot, highly reactive brines, groundwater. Also, then again, the lithostatic pressure gets totally nuts. So, and the rock you're drilling through actually moves in response to that lithostatic pressure. So that gets to be kind of tough.
Do you have any of those three problems on the moon? I know for sure you don't have the salty brines, but
No salty brines. You have a geothermal gradient, but it's not anywhere near as bad as on the Earth. But of course, then you're on the moon. And so it's a little bit remote. The other thing is, remember, this creep is actually on the surface, not because it's part of the regolith, but because it got erupted in basalts. And so there's a fair amount of basalt out there. And I think we're talking about a fairly big resource if you want things like thorium and potassium.
So just to clarify, you're saying the Marin basalt itself is a resource?
Yeah.
Okay.
It is incorporated the source region for the Moire basalt essentially partially melted that zone where the creep was enriched, because that's the base of the anorthitic crust.
Okay, awesome. Any other comments on what we have to do for a study of regolith properties to successfully extract creep?
I don't know. How do you mine thorium
on Earth?
on Earth? Yeah,
I do not know.
neither do I.
I have no idea.
Someone with a computer want to look up how you mine thorium real quick?
Thorium is
I don't
big,
know.
so it's near the surface, right?
It's concentrated. On Earth, all of these things to be mineable are concentrated by some sort of hydrothermal action or aqueous action.
Huh.
So it would be fundamentally different than on the moon.
Yes.
You know, you'd probably want to find yourself a creep-rich lava flow and grind everything up very fine and separate out the heavy elements.
Would you do that by centrifuging?
That's one way to do it.
It's monazite, MONAZIT.
Mhm.
It's 3 to 5% content thorium oxide.
Okay. Where do you find monazite?
India,
Okay.
Malabar coast,
All right. It comes in sand, doesn't it?
yellow to brown sand on beaches.
On beaches, yeah. You get that in Brazil too. The downside is that sand is kind of mildly to highly radioactive.
Should we get the tandem on with you at the same time?
That's right. There's a beach in Brazil where the annual radiation level is 3 times the annual dose of somebody who works at a nuclear power plant.
This must be taking
So-
fish.
So if you vacation, yes. Well, I saw a picture of this beach that was absolutely crowded with people. You know, and that has it gets 170 millisieverts a year.
So don't be a lifeguard at that beach.
Well, I'd spend a lot of time, or else sit in something thick like concrete.
Let my chance.
Yeah, if you're there, you're there long enough. Living their best life.
Well, yeah, your problem is really breathing in any of the dust from the sand.
Oh yeah, that's not
That would be ugly. But you know, people voluntarily go and hang out on that beach. But that's monzonite is one of these things that you have to watch out for.
So they don't have warning signs on the beach?
I don't read Brazilian,
So would this thorium on the moon also be radioactive?
Oh yeah,
Okay,
a little bit.
less or more, or
Well-
equivalent?
Depends on the concentration.
Okay.
You know, the level that the dose that you can get annually as a radiation worker is still way lower than the minimum dose where people tend to get obvious effects like cancer. So by about a factor of 10. So you're only going about a third of that distance.
But if you're on the
Renting a
moon,
beach house.
if you're on the moon, you're already in space and you're already dealing with
Well,
even more radiation.
If you're on the moon, you're obviously not
Just a
risk
little bit.
averse.
That's true.
Okay. When we're talking about minerals and resources of the moon, we also have to keep in mind the water. The water is found mostly in cold traps or in areas after impacts or from impacts. For a discussion question, there's a lot of those in this. If you could choose one site on the moon at which to look for water, where would you go? Where would you choose?
Like a region.
That's cool, right?
The south.
South.
Because that's where it's
Yeah.
the sun can't.
Yeah. So the cold traps are mostly at the poles, right?
Yeah. And it's kind of shown here. You're right on. The polar regions are where most of the water is. It's kind of in that form of crystallized ice, technically a mineral. And I really like this fact from Dr. Crane's presentation. An inventory of hydrogen poleward of the 80-degree latitude line exists with a total mass of 1,011 kilograms. What that means for water is 1,012 kilograms mass lunar surface. All that means in our terms is that's the equivalent of filling 3.6 million Olympic-sized swimming pools with water. So that's a lot of
100.
water.
100 billion and a trillion.
Yes, I know. Yeah, a big number.
Like, how
One
much,
Olympic-sized swimming pool is 1 megaliter.
how much water does like Orlando, the city of Orlando, use in a week?
Some.
I feel like it's something roughly just like this. Like I feel like that's not that much.
So I looked
Right.
this up, and that's 1/5 of the water in the Great Salt Lake.
But we don't drink that.
But okay, but it's a big volume. You can
Right,
see
no,
it on the
I've
U.S.
never
map. That's a
seen that.
lot of
I'm
water.
trying
Like,
to like put it in terms of like
how much water do people consume, and is it
yeah,
consumable?
like how
What kind of
if you use
population
that
can you
to, like,
support?
yeah, do a
Yeah.
moon base, like how like a week, a month.
No, I feel like well, you also have to
Not
figure
that
out how
many
many
people,
people. I think like several thousand people, and once you have the water, you don't let it go in space. You recycle it. So
That's
like
true.
the ISS has a better recycling system than like Earth stuff. So it's something like a factor of 10 times less harmful particulates in the ISS water than what you get on Earth, even though like it's made from recycled dirty water that the astronauts
But you're
have
not
put
only
out.
drinking it, right? You're using it for like
Yeah,
other
using
stuff.
but you can like they have a near perfect capture of water. You can, do an infinite level of recycling on your water.
An interesting comparison would be the Floridian aquifer, which runs all the way up to like North Georgia. I think that's what Orlando gets their water from, if I'm not wrong. And so I'd be interested to see like how much water is
So
left in that.
Average American family uses 300 gallons of water per day.
What's that in liters?
300 gallons?
What's that in liters though?
I would say
Multiply by
8.3
4.
divided by 2.2, or it's
Okay.
about 4.
So
1,200 liters.
there's 1,200 liters per
So
family.
it's a good amount.
There's
And then
3.6
average American-
million megaliters. Yeah,
Oh,
that's
Average
a
American's
lot.
going to be using a lot more
Okay.
water than I would think people that are trying to reuse everything.
That's true.
Well, there's a lot of water, and you're right. Look in the polar regions.
But you are going to get some of that taken away as probably fuel because water is both a water resource and a fuel resource.
Water jacket.
I'm also interested the difference in the total mass between the hydrogen and the H2O implies that there's probably like H2 gas, and that could also be a resource because it's explosive.
Good point. So now we're going to move on to the geology of impacts. The main idea with impacts is one of the important impact periods, I should say, was this period of intense impact cratering called the Lunar Cataclysm or the Late Heavy Bombardment, which is what I'll refer to from here on out. The impact dominated geological evolution of the moon is very different, as we talked about at the beginning of this talk, than Earth's plate tectonics driven geology. That's really important when we're looking at ISRU. So Dr. Green pointed out this is a really key ISRU idea, that impact cratering is the most important geologic process affecting ISRU on the moon, especially because on Earth we have those plate tectonics, we do not on the moon. It's very impact-driven geology. So with the late heavy bombardment and the effects of intense impact cratering, there were 8 kind of key ways that the ISRU potential on the moon was impacted by that. There's a lot of information for each of these points that Dr. Crane went through. I think for the purposes of our discussion, we're going to overview the 8 points. And then again, I really highly encourage you to go check out his presentation if you're interested in the finer points of any of these 8 ideas. So the first one is that impacts in the polar regions produced permanently shadowed regions, PSRs, that's what we're going to call them. And what's important is that these are places where volatiles can be trapped. Our second key idea is that impact asteroids and a few comets here and there also source volatiles that can be trapped in these PSRs. The largest impactors altered the spin axis of the moon, which alters the location of the permanently shadowed regions, PSRs, which are sources of volatiles. Yes,
I have a question about this one, because if it's altering the location of the PSRs, then now the sun's going to hit it, and then it's going to, would it not sublimate away? So why is that a good thing? Or it just doesn't sublimate that fast?
So I think if you had a PSR and then you had an impact and you covered your previous PSR with a layer of regolith, it's like you put it in the fridge.
Right, but that's not what's saying that it altered, like the spin axis moves, and so like the location.
Yeah, so you have, like, if it was still, it's not a permanently shadowed region anymore, but if you covered it in enough material.
What if the impactor happens like way away from it and it's not getting covered by anything?
Well, then it's gone. But there's potentially places that are not currently PSRs that were PSRs and still have ice reserves in them, I think.
So you have fossil PSRs.
Yeah.
Okay. But if it wasn't covered up, then that would be a bad thing.
Yeah, if the sun can hit it, yeah, it's gonna.
How much regolith do you have to cover up the ice with to keep it warm enough or cold enough to let the ice still be there now?
What a great experimental question we can
I
address
think
when we're on the
it depends on the
moon.
properties of the regolith and how compacted it is over the surface.
So
and then how much time has passed since it's accumulated before the sun affected it.
I was gonna say, in my lab, we do heating with a gas lamp and a vacuum. So everything just goes via conduction, and that doesn't conduct very far. You have like temperature gradients going from, I don't know, like tens of Kelvin down to from the bottom, and then going up to 300 Kelvin from the light, and within single grains.
Wow.
So you actually get cracking and stuff, but yeah. So I don't think you would need very much.
So the thermal skin depth for you is millimeters
Or less, yeah.
or less. Thermal skin depth is going to be a function of time, but it would probably not take all that much because, especially in vacuum, dirt is a good insulator because you just don't get, you need a physical connection in order for the thermal photons to be transmitted, and you just don't get good connections in these regoliths. If you get more compacted, you get better connections. But still, the material itself is not that terrible, is a pretty good insulator.
So is it kind of like house insulation that you want it to be really fluffy? I mean, because house insulation is based on air. So like what's the,
Right.
Is it
Well,
just if it's
that's-
really fluffy, it has less points it's connecting to, so it's
Correct.
going to conduct?
But it'll conduct through the air also, just not as well.
Sure.
Ideally, what you could do is you could get rid of all that fiberglass and maintain a vacuum in your walls.
Well, yeah, okay.
That would be wonderful.
That's
insulation.
super cost effective. I'll definitely
Well, we're not talking about business cases at the moment. We're talking about science.
Okay. But so I know there's like some talk about bagging up Martian soil or bagging up lunar regolith and putting it on the outside as like an insulation.
Yeah.
But it's also supposed to be like radiation insulation.
Sure.
So that's why it's better than just having the vacuum, right?
Correct. Well, the thing is, if you're going to stop a high energy photon or a charged particle, the rule of thumb is a mile of air. All rules of thumb apparently are in English units. A mile of air, 4 feet of dirt, 3 feet of concrete, 1 foot of metal. So keep that, roughly keep that in mind. All those are roughly equivalent. And it's essentially the
Density ratios.
density ratios and interactions with the particle. Because with any high energy particle, you're going to end up with other high energy particles once it interacts with something else. And you want to have enough interactions so that these things get slowed down and lose their energy and dissipate.
Okay, so continuing on with the 8 key ideas of how impact cratering is affecting the moon's ISRU potential. The fourth is that the largest impact basins have thinned the crust. This is important because large volumes of the lunar magma reach the surface and vented volatiles. This is another source of volatiles potentially trapped by the PSRs. So a lot of these key ideas have to do with PSRs and volatiles. From large impacts, ejecta covered and potentially could have reworked horizons of ice deposits in the PSR, which produces another like stratigraphic succession. Cool. Also, the impact basins provide catchments for lunar mare, these flood basalts that contained ilmenite, or that can contain ilmenite. Ilmenite can be modified to produce oxygen. Number 7, impacts have infused the lunar regolith with volatile abundances. These volatiles combine with the volatiles from the solar wind. They then can cover the surface of the moon. So this isn't just like an isolated like pockets of areas, cover all the surface of the moon and infuse with the soil to have meteoritic metal that can be there from impacts.
So this is like we were talking earlier about a little bit under the surface. If you have ice, it'll probably stay there because it's not going to get heat enough to sublimate. Is this the implication that if you have an impact, it has some kind of volatiles still in it, and it gets covered up immediately, it's not going to sublimate?
I thought it was just that's where it comes from.
Okay, so like it's just water trapped in crystals in the meteorites? Okay.
That was my understanding.
Yeah, because I think that would more be like number 5, maybe what you're saying.
Okay.
Because it's like potentially like reworking some of these ice deposits or covering them up.
Okay.
Yeah, I would say 7's more just kind of like the regolith comes in general. It's gonna be everywhere.
Okay.
So the largest impacts may have produced melt sheets. And again, a lot of melting differentiation, that's the main idea, which could have potentially formed ore deposits, specifically of metal and sulfide. Those are the 8 key ideas of how these large or the intense impact cratering events affect the ISRU potential of the moon. So a couple questions. What kind of challenges does impact gardening, and by that I mean when lighter, fluffy regolith comes up on the top from impacts, what does that present to ISRU?
I have a question. Why don't you just get like a leaf blower type thing and blow all that away?
I don't think a leaf blower works in the vacuum of space.
But like, you know.
Well,
like
rocket exhaust does, and
Right.
rocket exhaust will blow away the loose, fluffy stuff.
Yeah,
And
why
you
don't
see
we-
that.
Oh, we do that.
Oh, yes, we've done that.
Well, I think that.
There you go. It's been done again.
But it sounds like the meteorite stuff is mixed in with the light fluffy stuff too, and you gotta like
So we wanna
collect
also
it.
get
It's not shoving it away. It's gathering it in.
That's true, because there's the like meteoritic metals. That was one of the points he brought up.
Yeah, then. Yeah.
It's already in vacuum. No, there's already a vacuum. You're not gonna beat the vacuum of space.
The Texan thing.
Okay.
Cyrus thingy.
So you're going to do a reverse vacuum where you blow some air in and then you have
air, but you have like
a seal.
a boundary.
Can you make a good seal with lunar
I'm gonna guess
regolith?
no.
But you probably can't make
Well,
a good seal with the Osiris Rex
there
bending
is-
regolith. So.
There is an annual competition for robotic mining of this sort of stuff on the moon.
Okay.
And if you're inclined and want to go watch it, it occurs at Kennedy Space Center every year, I think in July or August.
Well,
You can actually make a team and go compete.
Has anyone ever seen one of those like mechanical things and it's got a bunch of little basins on it and they're on a conveyor belt and it like scoops water and like brings it to the top and then pours it in?
Yeah.
Wouldn't that be a better way to do it? Like have
Well,
something
the
constantly scooping
Swamp Works at Kennedy Space Center has a little thing called the Razor.
it?
That essentially is a whole series of buckets
Yeah.
that scoop out and mine. But what Kennedy does is that they basically mine the innovation of these 30 or 40 teams that
Okay.
compete for free right in front of their eyes. And you can talk to Phil Mesker about how people look at that data and see how this technology has been evolving over the last 10 or 20 years. Because it's a good way to innovate. So yeah, there's various ways of scooping this stuff up and delivering it to process plants. I have another question for you though. If you're actually concentrating veins or horizons of interesting stuff in the melt sheets, how do you access those?
Remelt it.
How do you remelt it?
Well, how do you know
Fire.
how do you know where it is?
I
Melt- Well,
Well, didn't we talk about last class it settles to the bottom of your melt sheet, the metals at the very least, because it's
they're
denser.
well, maybe. I don't know.
Because you're melting.
Okay.
Yeah.
You can do the same thing we were talking about earlier, just like take all of it, grind it up, put it in a centrifuge.
Well, but that's
Send it to recycling.
we're trying to think of a minimum energy elegant way of doing this.
Okay, well you didn't say that. You said get it.
Well, this is a good point, is that whenever you pose a question, you need to write your requirements very carefully.
Okay.
So,
So what's the most economic way to access it?
well, it's going to be constrained maximization on all your resources.
Right.
So I don't know what that is.
I think it really does depend if the metal does settle to the bottom or in like discrete areas, because it may not necessarily be the bottom. Bottom might be like along the sides.
Yeah.
But that's
And-
you need two entirely different approaches depending on metal is still mixed throughout or metal is.
So how do you know the stratigraphy of that melt sheet? How would you go about finding out?
Ooh, so
Can you
I
do that?
would.
Pardon me?
Can you radar it?
Well, I suppose, yeah, ground penetrating radar would help. What is a natural resource that you can take advantage of? Earthquakes? No, or moonquakes.
Moonquakes.
Make moonquakes.
Make moonquakes.
Well,
You can
other, is there something that exposes that stratigraphy?
Oh, impacts.
Impacts, yeah. Go look at craters. Go crawl down craters.
Could you also
Make
do
new
something
craters.
like sampling a bunch of different impact craters and seeing what the metal distribution is? And if you know that
Oh, that's a
20% of impacts are metal meteorites, then you expect 20% of your craters to be enriched if it's throughout. And if none of them are enriched, then you know that it must be
Lower.
settling at
Yeah.
least lower.
Well, also that there's, what you can do is sample a variety of sizes and see if you can discern the stratigraphy of that melt sheet by sampling those ejecta blankets from those craters.
Is that more cost effective than just grinding it up?
Well, I don't know.
'Cause have
Well,
to
if you
get
can
to
say
all these
like,
different
if you can say
things.
this particular one at the bottom of it has a big pile of metal, Yes, I think it would probably be easier to drill.
But if you have to like get to the different ones, is what I'm saying. You're gonna sample a bunch of different
Yeah,
ones.
but I mean, we'll do that anyway, just for scientific curiosity.
If you're going to try to grind up all
Yeah.
the, if you're talking about grinding up all the basalt in a basin, I think you can get around to just sample.
Mm.
And probably whoever
And
is
send out a bunch of
financing your
reagents.
grinding would want to know how long it's going to take to get to the ore horizon. And and it would be helpful if you could have convincing proof that it actually exists.
So this is like almost hearsay because I saw it on a Discovery Channel documentary, and it's not something I read in a scientific journal. But
That's
Was it
that's
after
2
10
strikes
p.m.?
against you.
I know.
So, did they start with some scientists say?
It's just science.
I watched it in middle school, so this has been out for a long time, and I haven't heard of it happening in the scientific community. So that is incredibly suspicious. But in the mid-aughts, there was a documentary about how someone at MIT had developed a method of turning lunar regolith into a solar panel automatically with a robot. And then, of course, Discovery Channel continued to turn this normal thing into a crazy thing by being like, you could let loose a bunch of robots and they could cover the moon in solar panels and you could beam it down to Earth as a death weapon. That's not important.
Death Star.
Yeah. But assuming that, has anyone heard of like, is the scientific basis at the beginning that MIT has found a way to make solar panels out of lunar regolith?
Well, what are solar panels made
They're
out
just
of?
glass.
They're just silicon.
Yeah.
Because there's a band gap in silicon that allows you to harvest some percentage of energy on incoming photons, right?
Yeah.
Sure.
Presumably. All of you people who have taken quantum in your sordid past. Well,
Now I know. Thank
you know,
you.
it was in a previous life that I took quantum. So. Anyway, so what you need is silicon. All this lunar regolith is basically silicon. It's kind of impure silicon. It would need a lot of processing to get rid of the other crap, but you could actually make solar panels out of such things.
So tying this back to this weird aside, back to our previous discussion, could you do something like that and like send out a bunch of
Robots.
somewhat self-replicating robots to sample these different craters?
Sure. Well, you don't really need to make solar panels in order to sample craters. You can.
Well, sure, but
But-
it makes it easier if you
That's
have
like a
little
resource.
like tiny like spirits running around. Spirits and opportunity rovers like on Mars.
The eventual
Sorry.
goal is to like have a moon base and build rockets on the moon to go places, and it would be nice to have solar panels.
Yeah, that's true.
Like that's something. We would
But you know, this is something that we can design a program to actually test the idea that these melt sheets have differentiated and have concentrated metals at some level in the melt sheet just by sampling the craters. Just to get back to that.
What on the moon do we not care at all about? Like, what is just garbage and we'll throw it away every time?
Well,
Or can everything be used for something?
everything except the squeak, as they say.
And the pig.
Yeah. I don't know. Most of the discussion in lunar resources revolves around either extracting oxygen from the regolith, and in which case it's the basic kind of rock that you squeeze oxygen out of, or getting water out of these permanently shadowed regions, and maybe some metals when you're making the oxygen. Because what happens is essentially you break all the bonds and you just have atomic silicon and atomic oxygen and atomic iron and titanium and magnesium and calcium, whatever is there.
Alright, I think we need like a creative or intellectual property claim on the Death Star, like killing off the Earth.
Well, Discovery Channel already did it, so it's out
no,
there.
You're right. I think
Thousands
that'd
of
be
bored
great
middle
movie.
schoolers witnessed
Yeah.
that, just like me.
I'm
think
still
it's-
intrigued by that.
It would be cheaper and more effective to throw rocks.
From the moon, just really
I'm just
big rocks.
thinking-
Oof.
When I was little, my little sister would be like, we should talk about AI. Like, honestly, not even that long ago when she was more little, she'd talk about like AI traffic lights or whatever. She was really obsessed with those. And she's like, what if they all got so intelligent they took over the Earth and killed us all? That's just what I'm thinking about the moon robots. Yeah, they got so intelligent they killed us all. But yeah, so kind of to wrap up, those are 3 parts. We had talked about the formation of the moon, the mineralogy of the moon, and the really important fact of impact cratering and the moon and ISRU. Looking ahead, kind of ahead and also current events, we have the Artemis moon missions. We're trying to land a woman on the moon. They already have an astronaut class picked out for this mission. Also, the goal is officially stated to land someone by 2024, which has some interesting social implications because that would be under the current administration. But we'll see. The moon.
2020, no?
Huh?
I
I
thought it
thought
was,
Obama won by 2020. He said we're
Uh,
going with something
No,
by
we
2020.
can talk later.
2025.
Let's talk
It
later.
is 2020.
And that's what I'm saying. That's what I'm saying. So like,
I honestly don't
okay,
know.
we're gonna 2024. No.
We can
I
talk
think
about this
they're
later.
talking about they're talking about the moon by 2024 if all the lights are green and everything aligns.
So no, we're not.
Of course not.
Great. So all
Nobody actually.
next astronaut class.
yeah.
You all do have a shot to be the first woman on the moon.
It would be nice if I had.
Well, not all of us have a shot at being the first woman on the moon, Dan.
I'm talking about you. I'm talking about the folks on this side of the.
You're gonna do it.
You don't know.
Space Force?
Do you see that the
no.
uniforms are camouflage?
What are they, black? White?
No, they're like Woods camo.
Camouflage.
They're Woods camo.
Oh god. Okay, well, land someone by something, and all that to say, the moon is a really important topic, like currently in the policy world, in the social world, and it's just going to be a more and more important topic. As we saw today, there's so many ISRU implications, so I encourage everyone to really keep on top of it and keep talking about it. We've had some really great discussions today, and I'd like to welcome any other questions, points of discussion, ideas.
Theoretically, how much would it take to go up the moon?
Okay, so first of all, we don't want to do that. I went on this.
No, I've just been thinking about it the whole time, and I've been waiting for the opportunity.
I went on a whole
That's
aside
why you're
recently
not
about
gonna be
why
first.
the moon is important.
No, I'm just hypothetically. Like, how big of a?
Just GMM over R squared. Right?
This is one of those
Pull everything apart.
Yeah.
scientists were so worried about if they could, they didn't think if they should.
Would it not have at least a couple negative impacts for Earth?
Oh yeah, the tides would get really messed up.
Hypothetically. Like, is it possible?
No.
What's the second?
No?
What's the second?
Well, the thing is that
What if we,
what's the radius of the moon?
bless you, big,
Big. You know.
3 Texas.
a fourth of the Earth's radius?
Yeah. So, presumably you would want to break everything up into small pieces.
Yeah.
But the small pieces are still going to be around. So essentially you'll take the mass of the moon and rate it down on the Earth.
Right.
Yeah.
But
Later,
Time
heavy.
machine.
Or-
that.
But could do that.
Well,
The biggest explosive we've ever had is like the atom bomb.
Well, about,
Well,
well,
it's
it's
probably
about
a meteor
Czar
impact.
bomb was
But like that we
57.
made. That
We
we
made
could make
about
happen on-
150 megatons.
Sure.
which
And
I
that
thought
just
was,
makes,
yeah.
I mean, a bunch of bad stuff, but it's like a crater. You know, like
Yeah.
it's not, it did not blow up
A
the whole.
fairly modest crater.
And the asteroid impact was what, 100 terajoules?
Yeah.
So, and that's still insignificant.
The big
Yeah, so
Russian
we
one in
can't blow up the
1910.
moon.
No.
We could
Don't
like,
say we can.
No, it's physically
Not
impossible.
yet.
We spent a million years manufacturing nuclear bombs. We wouldn't
Well,
be able to make a large enough crater to seep
okay,
the Earth.
if for some reason money was an object and the entire human race decided this is what we're gonna do, we're gonna blow up the moon, you could like aggregate a bunch of asteroids outside of lunar orbit and then direct them on a collision course with the moon.
I don't think that would do you much
I
good.
think it would make the moon bigger.
The asteroids near us are little.
You have to hit with like.
Yeah, you would have to do it
series
from
or
like
something.
you'd have to do.
You'd have to hit it with a
This is the entire human race decides for the next 500 years, our only goal
Is
is
just
to blow
fire
up the
all the
moon.
near Earth asteroids.
No,
So
I
I'd
think you
say
would have to go to the
500
main
years.
belt and collect a bunch there and put them all together and then send
Oh,
that,
the entire main belt.
not the entire main
Or
belt, but a
push the
lot of
moon
it.
Into the Earth.
That might be easier,
That might be
actually.
the easiest.
That
But
might
with
be
the
the
thrusters on the
easiest.
backside of the moon,
Well,
it's always oriented
But it's
that way.
going away already. We
Yeah.
have to
It just like an itchy.
Bruce Almighty.
Well, your
I got this.
problem is that the tidal coupling is pushing the moon away.
Yes.
Uh-huh.
If you try to push the moon toward the Earth, you can overcome that tidal coupling. Maybe you could overcome the tidal coupling initially, but what happens, of course, is that this is an inverse square problem. And as you get closer, the tidal coupling gets more effective and pushes it harder away.
Yeah.
So, no, I don't think that's the approach you want to take.
What about the collect a bunch of main belt asteroids and into one big thing that's still smaller than the moon and throw that at the moon?
Well,
And just keep.
I said a
hitting
bunch
back
of them.
Closer and closer.
sometime, somewhere in this whole process, somebody's going to stop and say, "Why are we doing this?"
Okay, look, Dan, I tried to solve it like the beginning, but we're all doing this.
This entire lecture.
As a counterpoint to Anisia's detonating the moon, is there any discussion of like creating conservation areas on the moon that are off limits for mining before we really get started
That's what I was.
The
strip
Apollo
mining
landing sites.
everything?
Yeah, that's true. I think
like
the
that.
Apollo
Those have,
landing
like,
sites are.
historical significance.
Yeah, I
but-
think they have their World Heritage organizations already.
Yeah, but those are like really small sites. Is there anything of like we're gonna make this whole like entire
this quadrant of the
Yeah,
moon.
this
I
is off
think
quadrant
limits.
there
is
has been
off
some
limits.
discussion along those lines. Part of it is that not just World Heritage sites, it's U.S. government property. And so the U.S. government claims some sovereignty over that material. And so if you go and, like break stuff off,
I mean, what are we gonna do?
You go up and just take the flag and bring this.
Yeah.
Oh, God.
I think we'd be pissed.
Like, you'd be pissed,
Yeah.
but like you can't
Kick
go.
the leg off
put
the
it
blue
back.
module.
Space race
Well,
number 2.
Well, the thing is that if
We have nukes, remember that.
there's certain functional reciprocity here. If you ignore other people's stuff on the moon, or if you mess with other people's stuff on the moon, you should expect them to mess with yours. And that's kind of a big issue in the minds of policymakers these days, is how do you end up with functional claims to areas of the moon? Do you just plop one of your landers down and say nobody can be within X number of kilometers because you don't want your ejecta from your launch plume or landing plume to mess with my stuff? And it does mess with your stuff.
There's a guy and he bought a Russian, or I think at the time it was a USSR, and then it became a Russian rover that had gone over a good chunk of the moon, and he argues that everything the rover touched and the rover are his property. So he owns a strip of the moon,
Okay,
and that's his argument.
I'm sure he can make that argument.
Again, who's gonna stop him?
Like the Space
Yeah.
Force, the space parks, national parks on the moon,
Yeah.
conservation sites.
Well, but how is he going to enforce his sovereignty?
Since he had nukes.
I think he's just a very wealthy man who was like, I'm
So
gonna
no
buy
nukes.
this rover and claim that I own the strip of the moon, and no
Yeah.
one can
Sounds
tell me
like free
not.
real estate.
Yeah, basically.
Well, there's an organization that for a price will,
Sell you a square foot of the moon. Yeah.
well, they'll sell you almost anything, but they'll sell you naming rights to stars or asteroids
Yeah.
or
But
whatever.
that's not real.
But what they do is that they put in a request to this international organization that does the actual naming. And the international organization gets the request and then they throw it in the recycle bin. I don't think it even goes that far. They get an email, they just delete it. They have it blocked permanently. And so the guy collects the money and, makes the effort, but nothing happens. There's
Drop
lots
into grad school, I got an idea.
there's lots of people that do dumb things like this. The fundamental thing is, do you have sovereignty? Yes or no? And
Start selling parts of like the UK.
yeah, you know, the,
I actually own a square foot of Scotland, so that's already happened. It's a conservation project. You can buy a square foot of a forest, and you
Have
can't.
you ever tried to go like sit on that square foot?
No, you can go you can go camp on it, but
Just
Just the square foot. You gotta stand.
but you can't
You
affect.
can't walk on anybody else's. You get airdropped.
My land now.
Back in 2 days.
You can't build anything on it. It's a national forest, and you own the land property rights, but you can't do anything. You don't own the mineral rights or like the timber rights. And it was this idea of let's get dumb Americans to give us some money so that they can put Lord or Lady in front of your name. Because in Scotland, if you own a foot of land, you're a Scottish Lord or Lady.
So Amy, you were the
Yes, I am the dumb American who did that. I thought that was an excellent conservation approach, and I was definitely into it.
So how much does it cost to get a title of nobility in a cold, wintry, windswept rock?
It was $35 when I did it.
Okay.
I bought one for my husband too. It was an
Good.
excellent Christmas present.
So Lord's, so you're both.
Are they next to each other?
I don't think so, no. You also get access to their golf club.
Oh, there you go.
Yeah,
And they will announce you as Lord or Lady at the golf club because
That's pretty cool.
Yeah.
I want a solid meter.
With
It's
your
only
luck.
$35 per square foot.
you can get 10 square feet as well.
I don't want 10. I want.
Okay.
Well, that's enough to lay down.
Yeah, that's true.
It's small.
What's your little climb?
With my luck, I'd get it and I'd go there and just be a tree there and I can't leave.
It's like
To bring the discussion
Sorry.
back to
yes, right.
the issue of conservation zones, I think people have been talking about that. The problem is going to be to get broad agreement to enforce these things. And all those scientists would like certain conservation areas. There's a lot of different players here. And whether the governmental and the private players will play nicely is another story.
Well, isn't there a good Earth analogy in this though in Antarctica? Yeah.
Well, yes, but Antarctica was placed as a scientific preserve mostly because it was too much trouble to physically exploit the resources. And it's still kind of too much trouble. But you get people that are violating sort of the scientific spirit of that by running tours to Antarctica. And there was a company a decade or so ago that was going to do a meteorite collecting tour of the blue ice areas in Antarctica. And those things are supposed to be off limits scientific preserves for the national expeditions. And
So wait, was it that the tourists could go find a meteorite and say, cool, this is mine, and take it home?
Exactly.
Oh, it's not free labor.
It wasn't sponsored by any of the national.
They should do that, but one for me, one for you.
Or like you get to
One
keep
for you.
one and all the
Two
rest
for
the
me.
government.
No,
One for you, three.
someone like that should be put back on the plane immediately after they step off. I'm sorry. That's a preserve for serious scientific expeditions, not for a bunch of yahoos going around picking up rocks at
Rich
random.
That's not,
Rich yahoos.
that's the worst kind of yacht.
Well, so what I did was I called up the guy who's supposed to be the guardian of such things at the Smithsonian and told him that he needed to do something right away. And he said, well, we've known about this and just wait and see. And what happened was that this person never got enough funding or the right permissions or whatever. But it's not like you send the FBI and go beat him up or anything.
That you know of.
That I know of, yes.
Dude, what if someone just takes a boat down? Is there anyone, like, there's no
Well,
Coast Guard
actually,
in Antarctica?
no, there's,
Is there?
They have like
There's
That's what the flat earthers
there's
think.
McMurray-
There's like aircraft carriers and
There's
everything.
McMurray Research Base, and it's a military
Well, no,
zone
there's-
as well.
But I would avoid that if I was
there's
gonna do
lots
it.
of research bases in Antarctica. There are companies that run cruises down there, and they actually copter you onto the continent or drive you over there on boats from your cruise ship. And I've known people who have actually taken those cruises.
rich yahoos.
Ooh, look,
Rich yahoos, yes.
But they can't go all the way to the pole, right? That's
No, well,
they only
that's,
stay on the.
I think that
That's
goes
a
out to
serious-
South America.
yeah, well, you need,
Peninsula.
it's a long way and you'd need serious support. So typically you'd base out of someplace like McMurdo Sound, which means you'd have to have the permission of the people who run that, the National Science Foundation.
You just pull up to McMurdo. Hey.
Years ago, various airlines ran sightseeing tours over Antarctica. And so you'd fill up a DC-10 with 300 tourists and you'd fly down to Antarctica from South America or New Zealand. And you'd drive around McMurdo Sound and enjoy the view of the volcano that's right next to it, Mount Erebus. And one of these DC-10s, because the weather in Antarctica is not that great, and it's a long flight, and quite often you end up not seeing anything. One of these DC-10s flew into Mount Erebus and killed 300 odd people.
Holy
But
And
also contaminated it.
well,
That's the lesser problem.
it's an active
It's a problem too, though.
it's an active volcano, so you know it's okay. The problem, of course, was that the staff at McMurdo then had to go out and collect 300 bodies, which was not the most pleasant thing
To
in
be
the
fair,
world.
they probably didn't smell.
Oh my god.
No.
Very hard, just.
Well, it was covered by the smell of sulfur.
Anyway,
We gotta pick up on it.
and the reason why this, you know, the cloud deck was kind of low, and they were flying around trying to see if they could get a view of the mountain.
They
And
did.
They did.
And they did.
They got up close and personal.
So I read about this in Aviation Week, and what Aviation Week does is it, in these accident reviews, is it publishes the transcripts of the cockpit voice recorder, which are kind of chilling because this is a long flight. They had 4 pilots. So you had the captain of the plane and then lots of assistants. And the cockpit crew was just viciously arguing with each other about where the mountain was. And one of the things that you get on these planes is when the ground starts rushing up at you, you get altitude alarms. And if you're at the same altitude and you keep getting an altitude alarm,
Yeah.
that's a bad sign.
Yeah.
And so the last conversations in this cockpit where they were getting altitude alarms and the chief captain said, "Turn that damn thing off." Yeah. So that's the problem with tourism in Antarctica is that the Antarctic powers, after that happened, thought, wow, what would we do if you had an accident where you actually had survivors and you had to rescue people? How would you be able to do that? And of course, the answer was you wouldn't. Whoever survived would still die. And so they banned those kinds of flights.
Good.
Yeah.
Or at least the U.S. banned U.S. airlines and U.S. sponsored charters from doing it.
There's other countries.
Yeah, there are. There's no shortage of irresponsible actors in the world. But this is one of these things that the analogy for the moon is that we still have plenty of time to talk over whether you want to have some scientific reserves or preserves And I think that's a reasonable request. The problem, of course, is going to be that when you're running landers in and out all the time, you're going to be showering ejecta all over the place until you get a decent infrastructure with some landing pads going.
Wouldn't that be one of the first things you want to do though? Like
Generally,
create
yes.
base,
Yeah.
create landing pads?
Yeah, generally.
Is there any discussion, this is another weird aside, of like creating something like maglev based landers? So like that you would come in and you could like come along a long line and it would magnetically slow you down instead of using like altitude friction?
I don't know of anything like that.
Okay.
Like roller coaster.
Yeah, I think that would be sweet, and I think it's a slept on idea for the moon.
They do it on roller coasters.
They have like magnetic launcher ideas for the Earth, and so you could do the same thing
Yeah.
on the moon, but you could also have a magnetic lander. Right?
Yeah.
Be so sweet. And they could save fuel because you could turn the moon into solar panels and harvest the energy to run your maglev.
I feel a bit circular right now.
Sorry.
Okay, well, thanks for the discussion. Anybody wants some more king cake, help yourself.
All right.
And we'll be doing the Lunar Highlands crust next week.
Thank you, guys.